Dear students, Assalamu alaikum. How are you? Today I am going to solve a very important question, the past paper question, the latest one. That question is summer 24 and paper is 4-2. The question number is 6. You can see over here the question number 6 on the board. Three particles A, B, and C of masses 5 kilograms, 1 kilograms, and 2 kilograms respectively lie at rest in that order on a straight line. So the first sentence I will translate in mathematics and try to make the diagram over here. So what's the diagram will be? I have a straight line. On this straight line, I have different colors. Suppose the color is red. So that red is visible. So that is the straight line. Okay. On this straight line, we have three balls. The first ball is this one. Suppose this one. The second ball is over here. The second ball. The third ball is over here. This one is. Now we have the mass. So the name of the first ball is this one. That ball is A. The name of this ball is A. The name of the second ball is B. The name of the third masses are the third ball is C. So the mass of first ball is given over here. The mass of A that is given is equal to the 5 kilograms. Then we have the mass of B that is equal to the 1 kilogram. That is called mass of B that is equal to 1 kilogram. And then we have the mass of C that is denoted by MC is equal to the 2 kilograms. At rest on the start of the question, the rest in the order in this point is X. Over here, we have that point is X. Over here, that point B is on the point Y. The point C is on the point Z. Initially, A is at point A, B is at point Y, and C is at point Z. Particle A is projected towards B with the speed of the 6 meter per second. So this one is over here. A is projected on this one towards B. We have this one is, and its velocity is given. That velocity is supposed that 6 meter per second. So we have this one, the velocity of this particle is 6 meter per second. Am I right? Now the second particle, B, is at rest. B is at rest. At the same instant, the particle C is projected towards the point B with the speed V meter per second. C is thrown on this direction. We have this direction, the C, and it is velocity is given. That velocity is V meter per second. Am I right? In the subsequent motion, A particle collides and collects with the particle B to form the particle D. So first is the half part of the question, this one. Particle D then collides and collects with the particle C to form the particles E, and E moves towards C. So the first case is over here. These particles at this point, this particle reach over here. Before collision, what's the status of this one? And after collision, what's the status of this one? And we have to use the law of conservation of momentum. Okay, so B is at rest. I will write with the help of the different color. Suppose I will use the green color. So the velocity of B is, I will denote this one. The velocity of B is 0 meter per second. And velocity of A is moving with a 6 meter per second. And when they reach over here, they will collide. So before collision, what's the total momentum? So momentum of the both the particle will be mass of particle A multiplied by velocity of A plus mass of particle B multiplied by velocity of B before collision. So we have this as a mass of A according to the question that is given the 5 kilogram, if I'm not wrong. Then we have the velocity of A is given that is 6 meter per second, if I'm not wrong. Then we have plus mass of the B is 1 kilogram, and the velocity of B is 0. So I have that one is 30. Before the value of the momentum is 30. Now, after collision, what should be the total momentum? After collision, both the particles combine with each other, and we have the new particle D. According to the question, we have new particle D. That particle D is denoted by velocity of D. Suppose that this we have the velocity of D, and multiply by the mass of D. Mass of D is the sum of both the numbers, and plus, because other there will be no particles, that is the after velocity, they have only one elements, that will be 0. Mass of D means the mass of the A plus mass of B, that becomes 6 kilogram. So that of 1, 5 is over here, 1 is over here, that becomes 6 kilogram, and its velocity is capital V D meter per second. That will be 6 times VD. So by law of conservation of momentum, both the momentums before the collision and after the collisions will be equal. So I will say that over here, this 30 is equal to this 6 times VD. So velocity of D multiplied by 6 is equal to the 30. If I'm not wrong, so I will get velocity of D is equal to the 5 meter per second. Now I will discuss the second scenario. What's the second scenario? V is moving this particle. C is moving towards the particle B, and now in this case the particle D is moving over here. I will make a new figure over here. The new figure will be just like this one. The new figure will be just like this one. If I have this one, the new scenario over here, and over here I have the first one is, that is a particle D. Its mass is 6 kg, because this is the combination of A and B, and it is moving towards this one. New velocity is 5 meter per second, and this is the particle C. Now this is moving this direction, in this direction. Okay, I'm right, and its velocity is V meter per second. So after the collision, both the particle will be combined. So D and this, both the particles will combine, D and the particle C, and that will becomes the particle E. So we have no information about this particle. We have no information about this velocity, and from particle E and moves towards the C. So this particle is moving in this direction. Its velocity is supposed to be V1 meter per second. Again, law of conservation of energy. I will explain over here. Before, what's the total momentum is? 6 times 5. 6 times 5 plus what's its velocity is V meter per second, and its mass is 1 kilogram. So V times 1, that is becomes 30 plus V, if I'm not wrong. So after the collision, what should be the total momentum? After the collision, the mass of the total particle E. So I will write this one, the mass of E particle, which is the combination of the particle A, B, C, and we have its velocity, and this velocity is V1 meter per second. So that velocity, just a minute over here, that is mass of E multiplied by its velocity, that is called V1 meter per second. Am I right? So that becomes, what's the mass of particle E? Consisting of the 3 masses, that becomes 8 kg into V1. If I'm not wrong, that will be the situation. So now you have to find the velocity V1, because what should be its velocity? We have to equalize both the values. And remember that this before the mass of the C particle is 2 grams over here. So you have to write the 2 times V. So equalize both the momentum. By law of conservation of momentum, you have to equalize. By law of conservation of momentum, law of conservation of momentum, if I'm not wrong, that will be equal to the 8 times V1 is equal to 30 Mach plus 2 times V2. Okay, one thing as over here, when the velocity is opposite to the direction of the motion, so its velocity will be minus V1. Make it correct better. So over here, that becomes plus 2 times the mass of the particle C, and its velocity will be minus V meter per second. So I have this one minus 2 times V, if I'm not wrong, minus 2 times V. So V1 is equal to the, when you simplify, taking common this from here, 2 is taken as common. So you will get the 15 minus V divided by 8. After cancellation, I will get 15 minus V over 4. That is the required velocity. That's the answer of this question, the first part of this one. Now, remember that is the situation. I will write over here. Its velocity of the particle E. Velocity of E is after the collision. That is equal to the, according to this question, that is 15 minus V times over 4 meter per second. Now, I will erase the whole things so that I can solve the next part of the question. Remember the whole thing step by step. The second part of the question is, now we have this one, the second part of the question. I will make it. I have to move the next one. That's the second part of the question is. This. No, according to this question, I have this one is, where is my calculator? That's my calculator. So I have to solve this question over here. I will make it clear. Again, the total loss of energy of the system, the total loss of energy of the system, the total loss of energy of the system is 63 joules. And whenever we have to use the numerical value of the loss, we have to put the minus sign. So I have the loss of kinetic energy that is equal to the 63. And whenever the word loss, you have to put the minus sign. Am I right? So now we have this one where the energy is lost. I will draw a rough figure over here. Suppose that's a no, this one is only discuss before the second collision, the collision of the particle D and the collision of the particle C. Before collision, what was the total energy? And after the collision, what was the total energy? So over here, I have this one. That is suppose that the particle is D over here, and its mass is 6 plus 1, 5 plus 1, 6 kg. And it is moving towards this one with velocity 5 meter per second. Then we have this particle is C, that is moving with the 3 meter per second. Its velocity was 3 meter per second and its mass was 2 kg. Am I right? Now, after the collision, what did happen? That's a zigzag line shows the collision. So it becomes the particle E, the single particle E. Its velocity becomes 15 minus V over 4 according to the previous part, and that particle is moving in this direction. And the next one is mass is the sum of the three masses, that becomes 8 kilograms. So we have the first one is we have to find the total energy before the collision. So total energy before the collision, I will use this mark. So total energy before collision. that is equal to the before collision, the energy of the particle D and the energy of the particle C. So the energy of the particle D is 6 times 5. So we have before the total energy, the kinetic, not using the kinetic energy, half we have this one, and the mass of the particle D is 6 into V square, that becomes the 5 square. So plus the total energy means before cooling, the particle C is the 2 kg, its velocity is 3 meter per second. Already we have to prove this one, value of this one is 3. So that's not the 3, that is equal to the V meter per second. Am I right? So half as it is, no, its mass is 2 kilogram and its velocity is V square. So after the simplification, I will get 3 times 5 square, it becomes 75 plus V square if I'm not wrong. So total kinetic energy after the collision. So total kinetic energy after the collision. So what will be total kinetic energy after the collision? After the collision, that will be the half as it is the mass of the particle E. The mass of the particle E is 8 kg. And what's the answer of this one is, it becomes half mv square. The v square is 15 minus v over 4 whole square. That is cancelled by this one. I will get the 4. So then I expand the whole square. I will get the 15 square becomes 225 minus 15 to the 30v and minus it becomes plus v square divided by the square of the denominator, that becomes 16. So it will be, that will be equal to the, what should be it? Suppose that after cancellation, that becomes 1 over here and that becomes 4 over here, if I'm not wrong. So what will you do over here? So the total energy becomes over here is that becomes over here is equal to the 4 is cancelled out, 4 over here, that becomes 225 minus 30v and plus v square divided by 4. Whenever you have to find the change of kinetic energy, so change of kinetic energy will be equal to the final energy minus initial energy. Always you have to write the after the collision energy minus before the collision energy. So after the collision and before the collision, the total kinetic energy. So I will have this one is 225 minus 30 v plus v square divided by 4 minus, then you have this one. The second one is, if I'm not wrong, that becomes just observe over here. Before the collision, what was the total energy? I will make it short. I think there is some mistake. 5 plus 1 half mv square. Its velocity will be 5 square. So I have this one is step by step. I have to simplify. You will get the answers. A little bit over here. That is, I think, maybe possible something wrong over here. Half m v square. Then we have this one half m 6 square, that becomes 6 is the mass and multiply by 5. 75 minus 90. Why so the 90 is because the velocity is moving in the opposite direction. So 75 plus v square. So I have this one, 75 plus V square, if I'm not wrong, that is equal to over here. And on the other side, I have, this is a loss because the loss is always minus 63, if I'm not wrong. So take the LCM, try to simplify. What will be the answer you will get over here? Take the LCM, try to simplify what is over here. So 225 minus 30 V plus V square divided by 4. On the other side, it becomes, sorry, minus V square over here. That is, a minus V square is equal to the minus 63, and minus 70, it becomes plus 75. So what will be the answer over here? Minus 63 plus 75. Make it, just I want to find what is this one is 75 plus V square. I think there is something wrong with the particle C. C is moving with the V meter per second square. And that is, say, half 5 meter per second square. Just I want to check what is the total mass, the total over here. 3 times and 6 means 36, 90 meter per second. So over here, I have this one is, after simplifying, what will you get over here? 225 minus 30V plus V square minus 4V square, and you have to multiply by 4 multiplied by this quantity. That becomes minus 63 plus 75. 5 minus 3 becomes 5 minus 3 becomes 2, and 7 minus 6 becomes 1. So I think over here, when we are solving this question, the previous data is, if I'm not wrong over here, 1 by 2, 6 times minus 3, it becomes this one over here, 75. That becomes the 90, sorry, that becomes the 90 over here. If I'm not wrong, that becomes the 90 over here. Okay, that becomes a 90, and it becomes the 90 over here. If I'm not wrong, that will be the 90 minus 63. So we have just subtract the things. You calculate 90 minus 63 becomes 90 minus 63. That becomes 7, and 8 minus that becomes 27. So that is equal to 27. When you simplify, you will get the minus 3 V square minus 30V, and minus that becomes 2 to 5 minus 4 7 so 28, and 4 2s are 8 plus 2 10. So after simplification, I will get minus 3V square minus 10V, and at the end you will get plus 15 minus 8 becomes 7, 11, 1 is over here, and 2 minus 1 becomes 2, is equal to 0. Now that is the quadratic equation you will solve with the help of quadratic formula or midterm breaking, as you like. So I have to solve this term over here. How I will write over here, just like this one. So it becomes minus is taken as common, V square plus 10v and minus 39 by taking common over here. When you make the factors, the negative factor will be 1 plus 13 into v minus 3. So there are three answers over here. So the first answer is v plus 13 is equal to 0. And the second is v is equal to 3. So that answer will be wrong. That answer will be correct. Okay, is there any problem? Because over here, this one, 1 by 2, we have as it is, the half, and 2, this 2 is this one. And after the collision, we have this velocity. So before the collision and after the collisions, before and after the change in kinetic energy will be 3. Now, the last part of the question is over here. The last part of the question over here is just I erase the whole things. Then I will explain this one step by step. So I'm erasing this one. Clear my all drawings. Now the next one is, the next part of the question is, wait a minute. The C part of the question is, it is given that the distance xy is 36 meter and the distance yz is 98 meter. Find the time between the two collisions. Find the time between the two collisions. So what's the meaning of this one? I will make a diagram over here. So that's the diagram, just like this one. Just you have to understand. We have to discuss the time between two collisions. After one first collision, what is the information? What type of the questions do you have to solve? This one is over here. Suppose this one, first collision is, we have the time is equal to 0 after first collision, and after first collision, the particle will exist, the particle D. That is a particle D, and its mass is equal to the its mass. Sorry, its mass is equal to the its mass is given the particle D is the collection of the particle A as well as B. So its mass will be 5 plus 1, 6, 8, if I'm not. And it is moving with the velocity after the collision. It is moving with the velocity of 5 meter per second. Am I right? So particle is D is over here. That's the particle is over here. Before this one, the particle will be C over here. That's the particle C. So the particle is a C on this place. So that particle is at point Z. That particle is at point B. And that particle at point A. Over here, we have the A over here. So the first thing is that this particle, when collide this one, after how many times, how much time it will collide with this one, we have to draw the line over here. So this particle is moving with the velocity 6 meters per second, if I'm not wrong. And that whole surface is the smooth. There is no opposing force, there is no friction, and A to B, the distance according to the question is that is 36 meters. So that's the distance is given over here, 36 meters. So I have this distance is, that distance is equal to the 36 meters. Suppose this distance is equal to the, with the green color, that is 36 meters. Okay. Now that distance is given from this point to this one. That distance is given that is 98. So I have to write 98 over here, and I have to write 36 over here. So how much time is needed to first collision from A to B? We have this velocity S is equal to V times T. So the time will be 36 distances, velocity is 6, and time is this one. So we have the time is 6 seconds. So C also, because the instantaneous motion through at the same instant, so this particle will also move in this direction over here. That particle is moving in this direction. So after 6 seconds, where will be this particle? After 6 seconds, the particle will be over here. This particle will be over here. So that is 6 seconds. Sorry, yes, that's particle 6 seconds. Its velocity is v, and previous part we have to prove that the v is equal to 3 meter per second. So how much distance the particle will cover? The particle will cover this much distance up to over here. That distance up to this point, this one, the distance will be, if I'm not wrong, 6 times 3, that becomes 18 meter. So what's the remaining distance from this point to this one, between these two? That becomes 80 kilometers, if I'm not wrong. So that distance is 80 kilometer. Now we have to solve. So we have 80 kilometer distance. The new data will be just like this one. Sorry, beta. The new data, we have to find when this particle will reach over here. Suppose this is the new point of collisions over here. This is the new point of collisions. Okay, I will draw the new figure to understand all these things. Suppose we have this one. I need over here. So the first particle D is over here. It will be just like this one. The first particle, no, I have this one is D, and we have this one is particle C. So that particle is D. That particle is C. Now its velocity is particle V's velocity is already we have this one. D is moving with the 5 meter per second after the collision. So that particle is moving in this direction. That distance is that velocity is 5 meter per second, and that particle is moving in this direction, and its velocity is 3 meter per second. So that is 5 meter per second, and that is moving in 3 meter per second. And we have to find that distance, because the remaining distance, that distance is according to the our previous data, that distance is 80 meter. So that distance is 80 meter. So suppose that both the particles collide over here at this point. That is the second collision. So how much distance this particle C will cover? How much distance this particle D will be covered? So I have to change the color of this one. Suppose the color is now, suppose the yellow. Yellow is not used over here. So the next one, this color is suppose this one. If I suppose this one is X, that will be the 80 minus X. Time remains same. So the particle will take the time over here. So that is called X meter, and that becomes 80 minus X meter. Time for both is T second, time for the both is T second. So that the distances are given, the time but the velocities are different. So how you will calculate this one? The time are same. The first one particle D, the formula we have S is equal to VT. Am I right? So S is equal to the distance is 80 minus X meter is equal to this, is equal to the D. S is equal to V. V velocity is 5 and time is T seconds. For this one, X is equal to the velocity is 3. Now we have these two equations, solve these two equations. and I will get that T is equal to the 10 second. So before the first collision and after the first collision, the total is 10 second time. Okay, the rest of the work I will do later on. Thank you, beta. Allah Hafiz.